Bismillahirrahmanirrahim. Okay, this is going to be solving radical equations part 2. Continue. So radical equations continue, chapter 11. So here's a little bit more trickier questions, not really that difficult, I think, inshallah. So now I have variables on both sides, and I have radical symbol. In fact, it's already isolated all by itself, so there's nothing attached to it like 3 or something like that. So I can square both sides, right? Sure. So I can square both sides, so let's square both sides like this. Okay, then I get rid of this radical symbol. Then I get p squared equals 2 minus p. Okay, to solve this, okay, I have to bring everything on one side. So I bring this p to this side and the 2 to this side by adding a p and subtracting a 2. Okay, so let me do it methodically. So over here, so I don't confuse you. So I have p squared plus p equals 2, and I subtract 2 from both sides. Then I have p squared plus p minus 2 equals 0. Okay, see, now this is a quadratic equation. Okay, if you, a quadratic equation, if you recall, there are 4 ways to solve them. Okay, you can graph them, correct? You can factor them. You can complete the square. And finally, you could do the trusty quadratic formula like this. B squared minus 4ac over 2a. Opposite of b plus or minus square root of b squared minus 4ac over 2a. Okay? In this case, I'm guessing I can factor this, so let me rewrite this. P squared plus p minus 2 equals 0. So let's try. P and p. Well, factors of 2 are 2 and 1. Now this tells me that the signs are different, and the bigger one is positive like this. Okay? So then I solve this. P plus 2 equals 0, or p minus 1 equals 0. Okay? Then p equals negative 2, and p equals 1. Okay? So I get 2 answers. Okay, but you have to check these answers because both of them or one of them might not actually work. Okay? So you always have to check these, and I'll tell you why some of them might not work in just a second. So I'm going to check these. So I'm going to erase my work over here because I need a little bit of room. Okay. So I'm going to substitute both of these in the original equations to see which one works and which one does not work, or maybe both of them work. Okay, so let's substitute negative 2 over here. So I have negative 2 equals the square root of 2 minus 2. So the question is this a true statement? Okay. So, okay, this negative 2 equals, okay, 2 minus 2 is square root of 4. Negative 2, does it equal to square root of 4 is 2. Is it equal to square root of 4? No, not on this planet. So this is actually an extraneous solution. It does not work. Okay, so let's try 1. Okay, let's try substituting 1. Does 1 equal square root of 2 minus 1? Is this true? Does 1 equal square root of 2 minus 1 is 1? Does 1 equal 1? That is true. So this is actually a solution. So there's only one solution to this equation. Okay? Now, why did we get a redundant solution? Okay, for example, now I give you this simple equation to solve, and then you say, well, I square both sides, I get x, and here I get 25, right? That's easy enough. So the answer here is 25, correct? But when you square and then you get like a square symbol, for example, when you say x squared is 25, so there are 2 numbers that give you 25, right? That's 5 and negative 5, correct? If you square 5, you get 25. Square negative 5, you get a 25. In our original equation, this was p equals square root of 2 minus p. this was one number here, okay? But when we square this side, we get p squared on this side, okay? When you introduce a square in an equation, okay, you're introducing potential solution into an equation that is does not originally belong there. Like if I had in mind only a 5 and then I squared and introduced also a negative 5. So when you're squaring an equation, in fact, okay, then you can potentially introduce new answers. In general, in algebra, the number of solutions to an equation, equals, at most the degree of the solution, okay? So x plus 5 equals 3, this will have one solution. X squared plus 3 equals 5, this can have at most 2 solutions, okay? A cubic equation will have 3 solutions at most, etc. So whenever you introduce an extra degree to an equation, you can potentially introduce a solution into an equation that does not belong, okay? So you always have to check these solutions to make sure they actually work, okay? I want to do one more question from here. Let's do this one. R equals this -1. So R equals square root of -1 minus 2R, okay? Okay, this seems easy enough, just like the previous one. I square both sides, I get R squared equals -1 minus 2R. Okay, so, well, working with our same principle from before, R squared, bring everything this side, 2R plus 1 equals 0. Okay, and okay, can I factor this? So R and R, 1 and 1, the signs are the same, like this. Okay, well, let's go. Then I get R equals -1, I get R equals -1 from here to get the same solution. So okay, so R equals -1. Okay, got that? Because if you substitute, if you divide this into 2, you get the same solutions. R equals -1. Okay, then we go to check. Okay, let's go check this. You substitute -1 over here. Does -1 equal the square root of -1 minus 2 times -1? Okay, does -1 equal square root of -1? This is plus 2. Okay, does -1 equal square root of 1? Does -1 equals 1? No, not in this one, not in our planet. So in this case, see, there is no solution. Okay, so in this case, there is no solution. Okay, so it's very important to check your answers. So in summary, we talked about radical equations. The way to solve radical equations is by isolating the radical to one side, and then you square both sides, and then you solve the equation thereafter as necessary. Until next time then, salatu wassalamu ala rasulillah, alhamdulillah rabbil alameen. Assalamu alaikum.